Okay, this is part 2 of topic 4.1, plate boundaries, plate tectonics. So now we're going to talk about divergent boundaries. In the last video, we talked about convergent boundaries. Now we're going to talk about divergent. And of course, you understand the word diverge means to split apart, right? So a divergent boundary is when two lithospheric plates are moving apart. There's really good evidence of this on the ocean floor. Let me go back here. We have the mid-Atlantic ridge here between Africa and South America. Actually, the mid-Atlantic ridge goes much further than that, but this particular graphic is showing that. So seafloor spreading is the process where the ocean floor is extended when two plates move apart. So here we have the molten material coming up from the earth, and it's spreading the seafloor, adding new rock to each side of the ridge, and it adds it in these kind of like ridges. So this kind of divergent boundary creates rift valleys, which are long, narrow valleys that run the entire length of a mid-ocean ridge. This is what a rift valley looks like, and this is actually how it happens. So it just, it slides down. So that causes that rift valley to happen, to be created. A good example of a divergent boundary is part of the Mid-Atlantic Ridge, which emerges from the ocean and splits Iceland in half. This is actually, let me present this so you can see. Sorry, I should have been doing that all along. There you go. Look at that. This is Iceland, and this is the Mid-Atlantic Ridge. This is what the Mid-Atlantic Ridge looks like, and here's Iceland. So we have the Eurasian plate moving east and the North American plate moving west, and where it's on the land, this is how it looks. And then we have underwater, this is the divergent plate boundary in Iceland. So you can actually, at certain points, touch both continents, which is really cool. The mid-ocean ridge is an underwater mountain range that was created from a divergent plate boundary, and it separates the North and South American plates from the Eurasian and African plates. And the thing with this is that you have magma coming up from the ocean floor. It's separating. It's, that's called seafloor spreading. It's spreading the seafloor. Where it's spreading, it's creating a layer of new rock and pushing the older rock out. So as you approach the center of the mid-ocean ridge, you're going to find younger and younger rock. Okay, so the basaltic oceanic crust becomes younger as it gets closer to this ridge. The older rock is pushed outward. So you have the increasing age of the crust from there. And then we have transform boundaries. And a transform boundary is just what it means. They transform sort of, they push past each other. This is a perfect example here. So we have two plates and they just kind of slide. They don't really collide, but they're up against each other and they slide. And these can result in catastrophic earthquakes. And the earthquake is when the stress overcomes a locked fault and it releases all that stored energy. The San Andreas Fault is 800 kilometers long and it runs throughout California. The divergent plate boundary evidence is found. It was found by scientists dragging a magnetometer across the ocean floor, and they discovered a pattern, a magnetic pattern where stripes of normal and reverse polarity parallel mid-ocean ridge, flipping every 200 to 300,000 years. The last one was 781,000 years ago. So it has to do with what's in the rock, within the content of the basaltic ocean crust. And they found that at certain times in history, the polarity is reversed. Sorry about the noise in the background. I hope you can hear me. And I guess the question for environmental is, how does plate tectonics affect climate? So over very long periods of time, I'm talking very long, millions and millions of years, hundreds of millions of years, plate tectonic processes cause continents to move to different positions on the Earth, and it can influence the circulation of air around a mountain. So like a big mountain range, it creates that rain shadow effect. And we might have the global air circulation patterns might be changed. It also, yes, so that's what I wanted to say about that. And these are beautiful pictures, and my time is up. So I hope you enjoyed this video, and I will speak to you again. These are nice pictures, right? Thank you.